In Lesson 14, Paul challenged us to integrate the Haversine equations introduced in Lesson 13 into the main GPS code that we've been developing over the last few weeks. The bulk of the code in this assignment is Lesson 12 code. As before, lat and lon information is displayed on page 1 of the OLED display. However, in this assignment, pushing the red push button will capture that lat and lon data. As we move along our route, pressing the red push button again will trigger the calculation of Haversine distance and heading between our current and previous location. The most recent Haversine results are displayed on OLED page 2. Pressing the green button will alternate the OLED display between one page and the other. In Lesson 15, Paul asked us to show the Haversine distance and heading calculations in action. We are expected to take the GPS tracker on a bit of a road trip. Let's have a look at the code. I'll gloss over the Lesson 12 code and focus only on the changes. After that, we'll take a walk around the neighborhood to prove it works. If you want a detailed review of the Lesson 12 code, there's a link to that assignment in the description below this video. We add math to our list of imports because of all the trig in the Haversine calculations. Pin and object declarations have not changed since Lesson 12. Variable declarations have been stripped down to suit this assignment. The GPS dictionary has been eliminated. Earth radius, Haversine distance, and Haversine heading are required for the Haversine calculations. Lat and lon have been converted to simple variables, and log index keeps track of how many waypoints we've logged. The red button ISR has changed in this assignment. When the user presses the red push button, we calculate the Haversine distance and heading if we've logged at least 2 waypoints. In any case, we update the lat previous, lon previous, and log index variables. Finally, we display OLED page 2. This section of the code is similar but not identical to Lesson 12. Since lat and lon are our key interests, we only parse GPGGA NEMA sentences. The OLED pages have been reorganized to show current lat-lon and a red push button prompt on OLED page 1 and Haversine information on OLED page 2. If log index is less than or equal to 0, we have recorded 1 or fewer lat-lon pairs, so we display a status message. Otherwise, we display the result of our Haversine calculations. The Lesson 12 heartbeat, fix, and page indicators have been removed from this program, as well as the data logging feature. The except clause is identical to Lesson 12. We'll test this logic with a short trip up the street to a local historic church. Below you can see OLED page 1 after we get our fix at the end of the driveway. Before we leave, we press the red push button to capture the latitude and longitude at the end of the driveway. The system displays OLED page 2 as shown below. Once we reach the front door of the church, we press the red push button again to capture a second lat-lon pair. Now we can calculate the Haversine distance and heading. OLED page 2 updates as shown below. Here we compare Haversine results versus the Google Earth ruler tool calculations. It's a pretty good match. I think it's mission accomplished. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.